Okay. Okay, so welcome to the SDGs Workshop 2025. I'm Dr. To of Kwansei Gakuin University. Professor Bibin and I will chair this workshop. So this year marks the 5th annual SDGs workshop. We're delighted to have so many participants joining us. Every year, we have the engaging presentations and lively discussion. We look forward to another lively discussion again this year. And before starting the presentation, I would like to invite the deans of the participating universities to give the opening remarks. At first, I'd like to invite Professor Hashimoto of Kwansei Gakuin University to give the opening remarks. Professor Hashimoto, please.
Okay, can you hear me?
Yes.
Okay. Selamat pagi. Good morning, everyone. It is my great pleasure and honor to welcome you to the 5th online workshop on the Sustainable Developing Goals. Today and tomorrow, we gather virtually from across Asia, from Malaysia, Indonesia, and Japan. Despite our graphical distance, we are united by a common purpose to explore and advance the theme of natural protection as part of our shared commitment of the SDGs. As I look through the program, I'm deeply impressed by the diversity and the depth of the presentations. We will hear about mangrove forest biodiversity in Malaysia, turmeric, germplasm, and traditional ecological knowledge in Indonesia, and sustainable wetland management in Japan. We will explore themes ranging from carbon sequestration using seaweed to the role of mangroves in plastic biodegradation, and even the use of natural dyes from East Kalimantan plants to protect our ecosystems. Each of these topics reflects not only scientific rigor, but also the profound creativity and local insight that are essential to the success of the SDGs. Together, they remind us that nature does not belong to any one nation. It is a shared heritage and a shared responsibility. At Kwansei Gakuin University, our School of Biological and Environmental Sciences is founded on the principle that learning must lead to action and that action must be guided by compassion and conscience. We believe that the challenges we face today, climate change, biodiversity loss, environmental pollution, can only be addressed by cultivating global networks of collaboration, just like the one we see in this workshop. What makes this event truly special is not just the academic exchange, but the opportunity for young minds and senior scholars to work side by side, across borders, across disciplines, across generations. Let me express my sincere gratitude to the organizing committee, particularly to Bibin Sensei and To Sensei, for orchestrating such a rich and meaningful program. I also thank all of you, the participants, for bringing your passion and perspectives of your commitment. May this workshop serve not only as a platform for knowledge sharing, but as a seed bed for future cooperation, innovation, and hope. Thank you, and I wish you all a stimulating and fruitful workshop. Thank you very much.
Thank you very much, Professor Hashimoto. Okay, and next, I'd like to invite Professor M. Rosie Ahmad of UiTM. Could you please give opening remarks?
Thank you, Prof. Hashimoto. Maybe today's on behalf of Prof. Razi. Prof. Razi, I had another appointment and say his regards to all of us. And I'm very sorry that we cannot come, and he can come on 12 o'clock. He has still a meeting today. Okay, on behalf of him, I'm from UiTM Malaysia. Say that very good and very thank you. It is honorable for us to join for the third time, maybe, yeah, Kang Bibin. This one third time for us to join this online workshop. And we are very happy that almost every years our student can inform and contribute to this workshop. And then thank you for the invitation, and this one very good platform for us, and especially for students to collaborate and to share our finding and our research to all of us, yeah, among Malaysian, Indonesian, and of course Japan as a host. So hopefully that everyone here can give and can have some fruitful benefit, yeah, for the information from anywhere, of course from Malaysia and from Japan and from Indonesia. So and then we from our Dean also hopefully that not only online, yeah. Hopefully someday maybe we can go to KGU, or maybe we can go to Indonesia, and of course from all of you from Japan and from Indonesia can come to our university as a mobility student. Maybe someday this we hope that someday this workshop can held offline, yeah, maybe in Japan or in Malaysia or in Indonesia. So that's what our hope. So and then following the SDGs, of course, KGU as the host, we are very appreciate for your initiation, and of course to continuing until now. It has been the fifth year, fifth time for this seminar and online workshop. Hopefully that we can continue and then more can collaborate and can invite more university as well from Japan or from Indonesia or from Malaysia also. So that's all maybe. Hopefully that we can make some more international ties, and hopefully that we can collaborate not only in this online, offline, of course. We can strengthen and and then worldwide more to not only for research and of course education and of course community service. That might be from us. Thank you very much. Assalamualaikum. Just a moment. Thank you very much and see you again.
Okay, thank you very much, Professor M. Roji Ahmad. I also wish to have the on-site program.
Yes.
Okay, finally, I'd like to invite Professor Abe Santo of UNDIP. Professor Abe Santo, could you give opening remarks?
Can you hear me?
Yes.
Okay, thank you. Well, good morning, everyone, and special honorable to Prof. Hashimoto Sensei as my good friend and also my senior, and also the other dean or staff or leader of its university. Well, today is very good that we can what you call it, its order, know about the university, also the student and everything. Yeah, thank you very much for the invitation, and I hope this moment can we do every year, yeah, with any issue that we can learn each other, because the most important of this activity is for the student. Yeah, for the student, it's very important thing. They can learn each other. They can learn anything in out campus or at their campus. So Once again, thank you very much for the invitation, and I hope I can visit every university which join on this event, a special visit to UNSIKA University, Japan, and we can make collaboration. So, Sensei, next November, I will visit Japan, and I bring one or two university that I want to make collaboration with you. But I hope to modify the, what you call it, major, because I will bring the faculty, the institute with major of economic sensei. So I hope can make collaboration with your university with the major of economy. So special for the student, could you please enjoy this event? Could you please explore your competency to make collaboration, international collaboration, special for my student from Diponegoro University. I hope you can learn anything in this moment. So I think it's enough. Thank you very much, Prof. Bibin, Simonto Sensei, and the other. And we can do this event and we can enjoy it. Thank you very much. Good morning.
Okay, thank you very much, Professor Abe Susanto. Okay, and next, the Professor Bibin have some announcement.
Yeah. Okay. Thank you very much for your joining today. So I think I would like to announce something. First is concerning about time duration for your presentation is 20 minutes, similar like the first until the fourth. Yeah. So the interviews similar, 20 minutes, and then if you have some question discussion, just 5 minutes. So total it will be 25 minutes. The other thing that I would like to announce is all participants must be in front of your computer, yeah. But please, if you admin, you can switch off the camera in order to take care about the connection, because sometimes we have some problem about that one based on our experiences. You can close your camera, yeah. But in the end of this program, please open all your camera because we are going to make some documentation. And then also we would like to have some permission from your side, yeah, if you have some kind of the problem, because we are going to upload this video to YouTube. If you have some problem, please send a message or information to us, yeah. In this case, directly maybe by chatting or maybe later on by email, yeah. In order, if you have some problem, you don't want to see your face or your voice, so I can arrange this one and I can edit. So I think that's all from my side. So now I'm going to return back to Chairman, to To-sensei. Thank you very much for all.
Okay, thank you very much, Bibin Sensei. Okay, then let's move to the presentation. The first presentation is given by UiTM Group 1. The title of their presentation is Unveiling Biodiversity and Biomass, Comprehensive Ecological Assessment of the Shijiangkan Mangrove Forest, Malaysia. Okay, if we are ready, please start the presentation.
All right, good morning, everyone. So we would like to present our ecological research titled Unveiling Biodiversity and Biomass, a comprehensive ecological assessment of the Shijiangkan mangrove forest in Malaysia. Before we begin presenting the individual findings of our studies, we would like to start by highlighting the shared foundations that connect all four of our research topics, which is the importance of mangrove ecosystem. Mangroves are coastal forests that provide a wide range of benefits both to the environment and to local communities. They serve as natural buffers that protect shoreline from erosion and extreme weather, including plant and marine species. The unique plant species found in mangrove have evolved specific adaptations to survive in harsh conditions, such as high salinity and low oxygen level. These adaptations not only support the survival of the ecosystem, but also hold great potential for medicinal use. In fact, about 10% of vascular plants globally are known to have medicinal value, many of which are found in mangrove areas. Unfortunately, due to rapid urbanizations and coastal development, mangrove forests in Malaysia are under significant threat, especially in Peninsular Malaysia, where the loss rate has been disturbing in recent decades. In response to this challenge, our 4 research projects aim to explore different aspects of mangrove ecosystem, from estimating tree value and carbon stock to examining morphological of mangrove plants and identifying medicinal plant potential. Together, this study reflect how vital mangroves are not just ecologically, but also in terms of biodiversity, conservation, and human well-being. Although mangrove ecosystems provide essential ecological services, they are under severe threat in Malaysia, particularly in peninsular states such as Selangor. Research shows that these forests are disappearing at rate of about 1% per year, largely due to climate change, coastal development, and human-induced activities like pollution and unsustainable land use. This decline has far-reaching impacts. First, we risk losing valuable carbon sinks that help mitigate global warming. Second, the unique morphological adaptations of mangrove plants, which enable them to survive in extreme environments that may vanish from being fully understood. Finally, and perhaps most critically, we stand to lose medicinal plant species that may contain bioactive compounds with pharmaceutical potential, yet many of these species remain undocumented or poorly studied. So this issue highlights that the urgent need for targeted research and conservation through our 4 projects. We aim to address this gap by contributing new knowledge of mangrove biomass, plant adaptation, and medicinal plant use. Our collective hypothesis is that mangrove ecosystem in Sejangkang hold high ecological biocultural value. We expect to find significant level of biomass and carbon storage in tree population, specialized morphological adaptation among plant species that allow them to thrive in intertidal conditions. A rich variety of medicinal plants with potential bioactive compound useful for pharmaceutical and traditional applications. Each of our projects focuses on validating one or more of these components through yield sampling and ecological analysis. These 4 research projects contribute meaningful to the broader understanding and conservation of mangrove ecosystem in Malaysia. From an environmental perspective, our study helped quantify biomass and carbon storage, which is vital in addressing climate change. By investigating the morphological traits of mangrove plants, we add valuable insight into how these species adapt and thrive under extreme conditions. From a biodiversity standpoint, we assess the richness of tree species, which are key indicator of habitat health, and we also focus on medicinal plants, an area of growth interesting due to the rising and demand for herbal and pharmaceutical products. Importantly, our work also aims to educate local communities, encouraging more sustainable interactions with these natural resources. By generating scientific data and raising awareness, our studies support long-term conservation strategies that benefit both people and the planet. Our study was guided by 3 main objectives. First, we aim to assess the ecological structure of the Sejangkang mangrove forest by measuring tree biomass and carbon storage, as well as observing how mangrove plants have morphologically adapted to their environment. Second, we focus on evaluating biodiversity, specifically looking at the diversity of tree species and medicinal plants using standard ecological indices. Lastly, we aim to explore the medicinal potentials of the plant found in the area by identifying species and analyzing their bioactive compound.
Okay, hi. Let's go through the methodology of our studies. For the study area, our study was conducted in the Sinjaka Mangrove Forest, located in Kuala Langat, Selangor. This area lies along the west coast mangrove bed of Malaysia and is characterized by tidal mudflats, brackish water, and dense mangrove vegetation. Although it is designated as a public recreational space, it's also rich in biodiversity. The site hosts a variety of mangrove forestry species, and medicinal plants. Its accessibility, along with its ecological richness, make it an ideal location for our multidisciplinary fieldwork. Our research covered several aspects, including tree biomass, species adaptation, and identification of medicinal plants. For the material, for the data collection analysis, we utilize a range of materials and tools to ensure precision and consistency. We use measuring tapes and string to record the diameter at breeze height, dBH. Then GPS device were employed for mapping the location of our quadrats. To identify plant species, we refer to field guides and identification kits along with camera equipments for species observation and documentation. Next, data were recorded in datasheets and later entered and analyzed using SPSS for statistical analysis. For the sampling techniques, we use the quadrat sampling method to allow systematic data collection across various vegetation layers and size classes. For mature trees, we use 10 meter by 10 meter quadrats. For sampling plants, 5 meter by 5 meter quadrats were used. To assess seedlings, we use smaller by 2 meter by 2 meter quadrats. In addition, for identifying and recording medicinal plant species, we applied transect walk method. A total of 4 transects across 50 meters long were established. With each subtransect, each subtransect include 10 meter by 10 meter quadrat to assess plant richness and distribution, specifically medicinal plants. For the identification of tree and plant species, for this part of our methodology, we focus on identification of the species in Sinjaka Mangrove Forest area. This process involved 2 key methods. First, we conducted consultation with experts. We collaborate with specialists and other experienced botanists to ensure accuracy for our identification of tree species. Their expert knowledge combined with the use of field guides and technology allow us to confirm the species found in high level of confidence. Second, we engage in collaboration with UPN and use Sinjakan source information. We refer to existing data and previous research conducted by UPM and the management of Sinjaka. This includes species list and local survey results, and which we use to cross-reference and support our own field identifications. Together, this method ensures a reliable and well-supported identification process for tree species present in the study areas. In terms of data analysis, our data analysis consists of 2 main components: biodiversity indices and biomass or carbon estimation. To measure our ecological diversity, we use several indices. The first one, the Shannon-Warner Index, measures species richness and how individuals were distributed. Simpson Index was used to assess species dominance and probability of encountering the same species. Palo Evenness Index evaluates the evenness of specific species distributions, while Magalhaes and Menhennick's indices calculate species richness in relation to the total number of individuals. For biomass and carbon estimation, we use these 2 allometric equations. The first one from Ong and the second one from Komiya 2005. Then we estimate carbon storage by using IPCC 2019 standards carbons equals biomass multiplied by 0.47. where 0.47 is the default carbon fraction in dry biomass. This allows us to generate accurate, non-destructive estimates of carbon storage potential, highlighting the important climate regulating function of mangrove forests. The last one, for this part, literature review method was used to identify the medicinal content and function of each species found at Sijangkang mangrove forest.
All right. My name is Abdul Wafi, and the next is for result and discussion. In our study, we recorded a total number of 131 individual trees representing 13 species across multiple quadrants in the Sijangkang mangrove forest. The most commonly observed species were Rhizospora apiculata, Avicennia alba, and Bulguera gymnorrhaeaca. These species are typical of Malaysian mangrove forests and are typical of Malaysian mangrove forests and are known for their adaptive features, such as silt roots and salt tolerance mechanism. The dominance of these species highlights the forest classification as a true mangrove zone, where both tidal influence and salinity levels plays a major role in species composition. The presence of diverse species, including both true mangrove and associate species, reflects the ecological maturity and regenerative capacity of the forest. Okay, next, to assess forest structure, we group trees based on the size classes. For example, less than 5 cm is for seedlings, and 5 to 10 cm is for saplings, and 10 to 20 cm is for pole. Our results shows that the majority of trees fall within the seedlings, suggesting that the forest is in the regenerative or recovering stage, with many younger trees growing. However, the presence of larger trees also indicates that all grow individual still persist, contributing to the biomass and structural complexity of the area. This distribution pattern is typical of secondary or regenerating mangrove forests where human impact has been reduced, but historical disturbance may have occurred. Next, the three species recorded in our study is 7 different plant families, with the most represent Rhizosporaceae, include Rhizospora and Bulguera species, and Avicenniaceae include Avicennia species, and Litteraceae, which include Ciliaceae. The dominance of Rhizosporaceae confirms the tidal and brackish characteristic of the environment, as these species are highly adapted to saline and waterlogged soils. By analyzing family level composition, we gain insight into the functional and evolutionary relationship that shape mangrove ecosystem. And next, for biodiversity indices. To evaluate species diversity quantitatively, we use several ecological indices, which is Shannon-Weiner Index, which indicate moderate into high diversity, suggesting that no single species overwhelming dominates the ecosystem. And Simpson's Index, where it shows that the likelihood of encountering 2 individuals of the same species is relatively low, reflecting balanced diversity. And for phyloeveness, it indicates that individuals are distribute relatively evenly across the species observed. And the last one is Margalef and Manhidek indices, which both reflect species richness, and the results support the forest harbor moderately rich tree community, which is essential for ecosystem resilience. These biodiversity indices confirm that Sijangkang mangrove forest is ecologically healthy and functionally diverse, supporting its conservation value. And for relative abundance, we calculate the relative abundance to determine the proportion of each species compared to the total number of individual observed. Our analysis shows that knife ruffle chicken has the highest relative abundance, making it the most dominant species in the Sijangkang mangrove forest. This species prevalence can be attributed to its strong adaptability to estuarine and brackish water conditions, as well as its ability to reproduce efficiently through floating foods and extensive rhizome system. Other species such as Rhizospora apiculata and Avicenna alba were also present but are at lower relative abundance. The dominance of nephroprotein reflects a specific ecological pattern, suggesting that the site contains area of soft, silty soil and perhaps more freshwater influence where these species tend to thrive. All right, for relative density measures how frequently a species appear in the study compared to the total number of individuals. Once again, Rhizospora apiculata ranked the highest, accounting for 85.71% of the total of the trees. This indicates that it is not only abundant but also widespread across the sampled quadrats. In contrast, some species such as Xylocarpus molescensis, Xylocarpus molescensis had much lower densities, suggesting that they are more localized occur under specific microhabitat conditions. Together, relative abundance and relative density give us a clearer picture of the dominance hierarchy and partial distribution of tree species in the forest. And next for the medicinal plant that we discovered, you when we use the transect in our field, sampling across multiple transect, we successfully identified a total of 277 medicinal plant species in the Sri mangrove forest. Among the species recorded were Acanthus illicifolius, Bruguera gymnohyza, Rhizospora apiculata, Avicenna alba, and several others, including common understory medicinal shrubs. These plants were selected based on morphological identification, habitat presence, and known ethno, ethnobotanical uses. Their presence confirmed the rich medicinal value embedded within the mangrove ecosystem and highlights the importance of conservation for future pharmacological and ecological application. And next, for the abundance of each medicinal plant species in all transect, our data shows that the most frequently encountered medicinal species were Nymphophortigum, followed by Bruguera gymnohyza and Rhizospora apiculata. Acanthus illicifolius was particularly dominant in the understory and edge areas, suggesting it thrives in semi-shaded and brackish microhabitat. This pattern of abundance is important for understanding how these species distribute themselves spatially and ecologically, often influenced by salinity gradient, light availability, and soil composition. Species with lower abundance, while fewer in number, may still be ecologically or pharmaceutically significant and warrant further investigation. And for the and to quantify medicinal plant diversity within the study area, we calculate diversity indices for each sub-transect using Shannon-Weiner index, um, and phyloevenness index. These results suggest the Sri Lanka mangrove forest hosts not only a fair number of medicinal plants species, but also maintain good ecological balance, increasing the resilience and medicinal potential of the forest. And to identify the bioactive compounds of each plant species, we conducted systematic literature review using academic journal, ethnobotanical database, and pharmaceutical source. Uh, some of the findings is um, as as these results demonstrate that mangrove forests and its jungle are not only ecologically essential but also offer real-world medicinal applications, some of which have yet not to be fully explored or commercialized. And for the last part, to conclude this section, we provide a summary that integrates data from all relevant ecological measures. For the species richness, the total of around 19 plant species documented, and for individual is around 131 plants is recorded, and for the and there is the 3 volumes and biomass, and also the carbon stock, where we use conversion factor 0.47. This multidimensional analysis shows that the Sri Lanka mangrove forest is not only biologically diverse and ecologically rich, but also holds tremendous pharmaceutical and environmental value that must be preserved. And next, I will invite our last presenter, Ms. Farhana, to conclude this project and suggest the recommendation to improve biodiversity in Sri Lanka mangrove forest.
Okay, so to conclude our presentation, we would like to highlight the overall significance of our research and the insight gained from the combined finding of our 4 studies. The Sijangkang mangrove forest proved to be a natural asset of high ecological, biological, and medicinal value. This coastal ecosystem not only play a vital role in environmental stability but also holds untapped potential in supporting public health, biodiversity conservation, and local livelihood. Through our analysis, we discovered that the forest stores substantial amount of tree biomass and carbon, positioning it as a critical carbon sink in the fight against climate change. This reinforced that the global importance of mangrove ecosystem in carbon sequestration and greenhouse gas reduction. We also observed that the mangrove plant species within the forest exhibit remarkable morphological adaptation, including stout roots, salt glands, and waxy leaf, all which enable them to survive in harsh, saline, and waterlogged environment. These traits are a testament to the evolutionary resilience of mangrove flora. And equally, we identify a wide variety of medicinal plant species, many of which are known to contain bioactive compounds such as alkaloids, flavonoids, and tannins. This finding confirmed the pharmaceutical and ethnobotanical significance of the mangrove forest with great potential for traditional healing and modern medicine. In summary, our studies revealed that the Sijangkang mangrove forests offer multifunctional benefit from the climate regulation and habitat provision to biodiversity conservation and medical resources. However, these benefits are increasingly threatened by urban expansion, industrial development, pollution, and habitat degradation. Our research therefore emphasized the urgent need for continued conservation, scientific documentation, and sustainable management of mangrove forests, not only to protect what remains, but to secure a healthier and more balanced future for both nature and humanity. So, based on the outcomes of our research, we have formulated several key recommendations to support the long-term sustainability of mangrove ecosystem, like one in Sijangkang. Firstly, we need to enhance mangrove conservation policies and strengthen enforcement mechanisms to protect remaining forest areas, particularly in rapidly urbanizing regions such as Selangor. And legal protection must be accompanied by strict compliance and regular monitoring. Next, we need to expand biodiversity monitoring programs by encouraging ongoing documentation of flora and fauna, especially tree species, biomass, and medicinal plants. Consistent scientific surveys can help detect ecosystem changes early and inform better management strategies. Then we need to promote sustainable harvesting and land use practice that allow for the responsible use of natural resources, including the medicinal plants without degrading the forest, and these include the adoption of low-impact methods and replanting initiatives. Furthermore, we also need to integrate local communities into mangrove management through environmental education, outreach programs, and ecotourism opportunities. Empowering the public to participate in conservation enhance both awareness and stewardship. And in addition, we need also to support interdisciplinary research that focus on important topics such as carbon dynamics, plant pharmacology, climate resilience, and interspecies relationship. Such research can deepen our understanding of mangrove function and their broader impacts. And finally, we urge collaboration within researchers, conservationists, and government agencies and policymakers to develop and implement long-term sustainable solutions. Only through shared responsibility and coordinated action we can ensure the survival of this vital ecosystem. So, in conclusion, mangroves are more than just trees growing by the sea, but they are actually guardians of the coastline, reservoir of the biodiversity, and the potential resources of healing for future generations. So, let us work together to protect them. So that's all for our presentation. We appreciate your time and attention. Thank you.
Okay, thank you very much, UiTM Group 1, the interesting talk about the biodiversity of mangrove. Now, the paper is open for discussion. Are there any question or comment? Okay, if no, I have one question about the medicinal plants. So you collected the information about the medicinal plants from the literatures. But are there any cases that local people use the plants for the daily health or something like that? So in the case of the Indonesia, they have jamu, so the ethnomedicine. So are there any case that local people actually use the plants for their medicine?
Okay, thank you for the questions. In terms of traditional use, based on the literature review, we have found that some species such as Rhizophora mucronata has been used in traditional ways to by the local ethnics to cure some disease such as for ulcer, for gastric, and so on. That's answering your questions.
Yeah, okay, thank you very much. So are there any question or comment? Okay, if no, let's move to the next.
Wait a moment.
Okay,
Sensei.
okay,
One question
okay.
from Japan, I think.
Okay, please.
What are some leads to the Zanka mangrove forest mentioned in the presentation?
Sorry, can you repeat the question?
What are some leads to the Zanka mangrove forest mentioned in the presentation?
Sorry, I think your mic is I can understand what is.
I think they asked about what kind of the treat to the Sikajang mangrove. Just for sustainable, this one. Hello? This group 2 asked about what kind of the treat for Sikajang mangrove.
What kind of the treat?
Mungkin ancaman gitu. Treat
Yeah, I
ancaman.
think yeah.
Ancaman Wafi, ancaman apa yang boleh terjadi terhadap pokok-pokok atau mangrove system di sana? Boleh? Dipersilakan. Dia.
All right. One of the most threats in Sri mangrove forest is commonly is urbanization, which is rapid development in nearby urban areas lead to land conversion and encroachment and loss of mangrove and cause of loss of mangrove habitat and the climate change, the rising sea levels, temperature changes, and increase the salinity stress, the mangrove ecosystem, affecting plants growth and survival. That's why a lot of old trees in the Siangkang is it's lower than the seedlings, which I have presented in the results. That the seedlings is more abundant than the pole and saplings, and this impact cause loss of biodiversity, decline in biomass and carbon storage, and also destruction of adaptive species. That's it.
Okay.
Yeah, I think it's okay. So, but someone anak Agung Gede Raka Dalam raise his hand maybe. Okay, directly you can ask.
Okay, thank you, Professor. I'm Raka, yes, from Denpasar, from Udayana University. I would like to know whether there is a kind of what's called local wisdom in your study side that bring impact to the sustainability of mangrove in that area. Thank you. Can you hear me?
Yes. The local wisdom that impacts the Siakan mangrove forest, I think, is on sustainable use of medicinal plants, which local communities have long used mangrove plants, such as national chicken, Rhizospora species, for treating illness like inflammation, infections, and uh, kidney stones. This traditional knowledge support non-destructive harvesting and encourage preservation of medicinal plants. And I also think that traditional ecological practice is one of the wisdom. Some villages practice tidal friendly fishing and avoid clearing mangrove for aquaculture or development, understanding their role in flood protection and fish reserves. That's it.
Okay,
Okay, thank
for Dr. Anak Agung, a bit additional, yeah. This Sijangkang Recreational Forest also is initiated by the local people, not by the government. So everything held by the local people, and then they do some sustainable for their mangrove area. This maybe for additional information. Thank you, Dr. Anak Agung.
Thank you. Thank you very much, Professor. Thank you.
Okay, thank you very much. So are there any question or comment? Okay, if no, let's move to the next presentation. Thank you very much, UiTM Group 1.